Thanks everyone for joining us today in our ongoing webinar series on data integration practices. Today, we're going to focus on continuous data ingestion into Snowflake. So we'll assume you have an interest in and at least some basic understanding of what Snowflake is. That's a prerequisite. In the agenda today, I want to talk more specifically about what we mean when we say continuous data ingestion. I'll go over three approaches that you can consider for designing a continuous ingestion process and provide some comparison between them so that that might help sort of guide your process as you decide how best to get your data into your instance of Snowflake. Let me set some preliminary context. We, CloverDX, we're a data management platform. So our expertise is most closely aligned with this third ingestion approach, right? I've drawn a little blue box around it. So when I get to the description, as I go through these, descriptions of these ingestion processes, when I get to this particular approach, I'll go into a little more technical detail, showing you some screenshots of ingestion pipelines that we built in CloverDX. So that's our specialty. I want to go over all three of these approaches, but you might naturally see us focus a little bit more on the one that we're experts at, right? Which is using a third-party tool, right? So two slides before we get started, just to further introduce ourselves, so it makes sense when we get to the point where we talk about using ETL tools. Our data management platform is designed to help you get data from wherever it is to wherever you need it to be. Today, of course, we're going to focus on continuous ingestion into Snowflake, but the platform is well suited for a variety of situations where you need to either replace a legacy system or your data is particularly complex or messy and needs some attention before you ingest, or when you have tight deadlines and you don't have the time or development resources to program a custom solution, right? So a data management platform could be helpful in those cases, right? Just a brief preview of our platform. I'll be showing you some design patterns that use this platform later in the presentation. Our data management platform has two pieces. Right, we have a design piece, a desktop tool that allows you to visually design and debug a data pipeline. And then we have a server piece where we deploy that pipeline. The server piece decides when to run the pipeline, runs it, keeps logs, alerts you when things go wrong. Again, the platform can connect to virtually any source system, provide virtually any type of transformation, and write to any target. But today, of course, our target will be Snowflake. So that's who we are, and that's what we do. Let's get into sort of refining or just digging a little more deeper into what we actually mean by continuous, right? It's a simple term, right? Deceptively simple, but loaded with meaning, particularly in this domain, right? So here's an initial definition, right? We want to keep the content of our target system, in this case Snowflake, up to date with the content of one or more source systems, and we want to do that at a rate that is fast enough that our business doesn't notice the difference between what's in our source systems and what's in our Snowflake. So in other words, we want to minimize the latency between the content of our source systems and the content of our Snowflake warehouse. Now, this latency, or the ingestion rate required to keep our users happy, Well, that's probably going to vary from business to business. It's not necessarily real time, which I use air quotes for. Either that or the term real time, we have to recognize is going to have different definitions for different companies or different organizations, right? Maybe once an hour is real time for some applications, like, you know, updates to real estate listings. But once a minute or even faster is the ingestion rate that you need for other applications, maybe IoT sensor data. So continuous doesn't necessarily mandate a specific rate of time, right? Could be anywhere from a minute or less to probably, you know, in our experience, continuous is typically, you know, at most, you know, hourly, right? You probably want to at least get it in there once an hour, right? Another aspect of continuous data ingestion to think about is that the data, we need the data load to continue essentially from the last time, to pick up from the last time. Each successive run of a process picks up where the previous run left off. So there's no breaks in the data, no gaps. And if our ingestion pipeline breaks for some external reason, right, it needs to be able to restart or go back and reclaim data, restart essentially without losing anything, right? If a network connection goes down or a source API becomes non-responsive, or for whatever reason your ingest process misses some cycles, when it resumes, when it picks back up, a continuous ingestion process should account for that gap and make sure that it gets any data that might have accumulated in the source systems since that last execution. So we need a continuum when we do continuous data ingestion, so we don't miss any data. And then finally, and this is perhaps a bit obvious, a continuous ingestion process needs to be repeatable. Pipeline needs to run on a regular basis, which could either be once per unit of time, or, you know, it could be asynchronous, right? Triggered by some data event, like the arrival of a file in some location or the addition of a row to a table. But in any event, the ingestion pipeline logic repeats on some regular basis. And given this need for repeatability, the invocation of each, you know, execution of your pipeline should be automatic, right? By a scheduler if you want to do things synchronously, or by some event triggering mechanism if you want it to be asynchronous, right? So repeated and automated, another important concept when we talk about the, sort of this broad, surprisingly broad term of being continuous. So we've covered the concepts or the characteristics of a continuous ingest: reduce latency, don't skip any data, be repeatable, be automatic. Let's look at some techniques for an implementation of a continuous system. So here are the three most common techniques we've seen for implementing continuous ingestion into Snowflake. Right, Snowpipe, which is Snowflake's own tool. Kafka event queues can be used in a continuous ingestion process, or of course a third-party integration tool such as our CloverDX, or actually hybrids, right? It's once you get into this, looking at these three techniques, you can see situations where you can use a combination of one or more of these to build the best ingestion pipeline, right? But let's go through these one at a time and get a brief introduction and talk about some of the characteristics. We'll start with Snowpipe. Here's a diagram straight off Snowflake's website showing how Snowpipe works. You set up some cloud location where the data to be ingested will land. In this example, that location is in the cloud, is in S3. So when a data file lands in S3, S3 sends a notification to the Snowpipe service. The Snowpipe service spins up, grabs the file, chunks it if it needs to be chunked, breaks it into bits, into pieces so it can be loaded in parallel, and then loads into the target Snowflake instance, right? So this is Snowpipe. It's a very attractive ingestion technique, right? It's cloud native. It's native to Snowflake, as well as being native to the cloud. It's serverless, so you don't have to manage any of the compute resources necessary to do the load. It's elastic, so it can increase in capacity with the volume of your data. And it's fast. As I mentioned, large files are automatically broken into pieces and loaded into Snowflake in parallel, right? But because it's serverless, elastic, and fast, it's also relatively simple, right? It can't do any in-flight transformations of your data. And so essentially presumes that any file that lands in that target staging area, in that S3 in this case, is already in the format that you're happy with pushing into Snowflake. Essentially, the files that arrive in S3 here are ready for ingest. Snowflake documentation recommends you deliver files via Snowpipe no more than once a minute, presumably because of this overhead of being serverless and elastic. It needs, there's overhead in spinning up the infrastructure to do that ingest. If too many files arrive simultaneously for a particular Snowpipe, they're automatically queued. That's great, again, for elasticity and to avoid skipping data. But note there's no guarantee that that queue is going to be processed in file order arrival, right? So you do need to take care if you end up using the queuing function or failing over into the queuing function, that you understand that the files might not be processed in precisely the same order that they arrive. Post-processing, if you need to do it after you load, that's going to occur on a separate schedule, right? So Snowpipe's listening for files and ingesting them when they arrive, but on a completely separate scheduled process, maybe to post-transform those files, right? So you need to, when you think about continuous, you need to understand that there's sort of two independent processes running. One that does the ingest, and then a separate process that might do some sort of post-processing to transform the newly ingested data. So that's those are happening in separate schedules, right? Snowpipe's not particularly unique in the world, right? There's a analog on the AWS side. If you want to use Redshift, AWS Pipeline offers a very similar capability to continuously load data into Redshift. Right. So that's Snowpipe for continuous ingestion. Here's Kafka, right? Using the Kafka streaming platform. Now, if you don't already have Kafka in your data environment, probably not going to be your first choice to use this as to implement continuous ingestion, right? There's some commitment required to build and maintain Kafka infrastructure. So if you're already committed to Kafka or plan on investing in Kafka, it can serve as an ideal source for continuous ingest into Snowflake. Here's a diagram, again, from straight off Snowflake's website, showing how they support the continuous ingestion from Kafka, right? Snowflake, in this case, is essentially configured to be a Kafka consumer. and then it will read events off of whatever Kafka topics that you've configured and copy them using Snowpipe actually into Snowflake. Again, this is probably best suited for architectures that are already Kafka-centric, say for IoT applications or when you're processing clickstream data. It's also getting increasingly common way to do change data capture from relational databases, right? There's a lot of relational databases, Postgres for one, that are capable of writing change data events to a Kafka log, right? So if you connect Snowflake to that kind of a Kafka log, you can automate the detection of every change to your source relational database and then continuously load into Snowflake using this infrastructure. Note that just like Snowpipe, there's no possibility for in-flight transformation. Your Kafka events are actually loaded into a Snowflake table as a single field of using the Snowflake type variant, right? Which is just a free, I guess, byte stream format, right? So it can be structured or unstructured, whatever your Kafka payload is, it's going to land in a single variant field in your Snowflake database, right? So you may find you need to do some post-load transformation to convert that data from its Kafka payload format into the format that you need for your warehouse users. And if you do that, that's going to be something you're going to have to do post-processing, with SQL or some other Snowflake enabled technology. And of course, your Kafka cluster needs to be exposed to Snowflake. There needs to be network accessibility so Snowflake can actually subscribe and become a consumer of your Kafka cluster. Right. Then the third way, finally, to do continuous ingestion into Snowflake is to use a third-party tool, integration tool like CloverDX, right? And I'm going to focus naturally on our platform here, right? We provide 3 different components to help you build continuous ingestion pipelines with Snowflake as the target. Right, that's represented by these colored boxes here on the screen, which are actually snippets of a CloverDX design pipeline. I'll show a little more detail in a moment. Our database writer component directly to Snowflake. So that it uses JDBC underneath, good choice for small amounts of records. We also have a Snowflake bulk writer component. Actually has a lot of capabilities of Snowpipe. It's fast, can automatically split a file into pieces and load in parallel. So for larger sets of data, using CloverDX, probably smarter to use the bulk writer. It can be, as it says here, up to 8 times faster than the database writer component. And then we have this final component, this purple colored component, DB execute, which is useful to execute arbitrary SQL or stored procedures on Snowflake post-load, right? So if you want to have a pipeline that pushes a bunch of data into Snowflake, and then after it's there, you want to do some sort of transform in Snowflake, you can design a pipeline in Clover that does that, right? ELT, where the transform essentially occurs post-load, right? Unlike Snowpipe and Kafka approaches, this is not serverless, right? We really need to have some compute up on Snowflake. Essentially, we need a Snowflake warehouse, an active Snowflake warehouse available to CloverDX in order to use these components, right? But let's look at these 3 colored boxes in a little more context. Here is a CloverDX data pipeline as it was designed with our design IDE, right? This pipeline takes a variety of steps to prepare a data set for upload to Snowflake, right? So there's no presumption that the data is just ready to go. We actually are going to run a variety of steps, a variety of transformations and reshaping and operation on the data before we push it up to Snowflake, right? We want to do a statistical profile of the incoming data, make sure it passed some basic sanity test, right? Is it roughly the expected number of records is a valid test? Are there, make sure there's no dates in the future or no null values in a particularly important field. We can do quick statistical tests of the data and fail fast and just stop. We're not going to do the upload at all if we can't get past this basic quality test that we do here. Then the next stage in the pipeline, we might want to reshape, to prepare the data, put it into a format that is more readily usable in Snowflake. So we'll reshape it, map it into a different shape. We can also apply some business rules after we've reshaped it and maybe pull out certain records that don't meet requirements, or for whatever reason, for whatever business reason, we don't want to load into Snowflake. And then finally, we might want to enrich the stream, maybe add some additional data that could be useful to our Snowflake users. In this case, maybe the name of the file that we happen to be ingesting, or who sent it to us, or what time we did the processing. All of this can be actually added to the record stream and pushed into the warehouse at the same time, right? So we're doing classic ETL as we prepare to have this data ingested into Snowflake. Right. Now, this is the logic for one particular file. If we want to make this automatic and repeatable, CloverDX will allow you to schedule this so that it runs once every few minutes or once an hour to go find those files to run through this process and ingest into Snowflake. Or we can trigger it, right? We can actually listen if we know that the file is going to arrive on an FTP site or into a directory. We can just monitor that directory, and the moment the file becomes available to the pipeline, we'll run this. So this can be synchronous with CloverDX or asynchronous, right? Either schedule driven, or we can listen to the data environment. So one pattern. The big difference here, of course, between this one and the other two, again, is that we want to prepare the data prior to ingesting it, right? Here's another example of a continuous ingestion pipeline in CloverDX. Here, the source is a Kafka queue, but instead of using the Kafka approach to directly ingest into Snowflake from Kafka, I want to do some operation on the data first, right? In fact, in this case, all my Kafka queue has, each Kafka item is just the name of a file that I need to go fetch and ingest. So in this pipeline, I pull an event off of Kafka queue, open it up, find the name of the file that I'm meant to go process, go grab that file, open it, validate it, run it through a bunch of transform steps and some quality steps, get it shaped right, then push it into to Snowflake. What's more, once that load is complete, I can use the DB execute component, the purple component right next to it, to post-process, to run maybe a stored procedure or some other additional SQL in Snowflake to process the data after it has arrived, right? So this is a pattern, if you're not familiar with it, called ETLT, right? Extract, transform, load, and transform again, right? And so you can see we're transforming the data first before we push it into Snowflake, and then immediately transforming it again after we load it into Snowflake, right? It is truly a continuous process from the arrival of data on Kafka on the left all the way through post-process data that's available in Snowflake on the right. So we're lucky, right? We have a variety of choices for implementing a continuous data ingest process for Snowflake. Which one is best for you will depend on your unique data requirements, but let's go back through these three real quickly and summarize and maybe provide some basic considerations for why you might choose one or the other, right? So choose Snowpipe, maybe when your input data is already in the cloud and already in a format suitable for use in Snowflake, or it's already in the cloud and you're okay running some post-processing SQL on some separate schedule from the ingest, right? That's important to note, right? That the post-processing that you can do once the data in Snowflake is in Snowflake, that's on a separate schedule. It can be scheduled to run at some interval, but it can't necessarily be tied into one glorified pipeline, right? Ingest and transform all in a single logical pipeline. It's actually two separate pipelines, an ingest pipeline and a separate post-process pipeline, which is scheduled separately, right? Snowflake documentation, as I mentioned, recommends at least 1 minute intervals between loads. So make sure that aligns with your latency goal. Scalability is, if scalability is key, I mean, Snowpipe is pretty slick, right? If you have the occasional massive spike in your data, Snowpipe's going to be able to handle that for you, right? Either deciding how best to split the files or, queuing them up automatically. Primary reason to choose Kafka, again, is if you're already committed to using Kafka and you have Kafka available, expertise available in your organization. You also need to be comfortable with the processing required to transform your Kafka payload. You'll certainly need to transform your Kafka payload from a Snowflake variant into whatever format is going to be needed by your users. And then again, like Snowpipe, you need to be okay with the fact that post-processing is going to be on a separate schedule from the actual ingest. And then third-party tools, choose that when you want to or need to prepare your data prior to pushing it into Snowflake, right? When you want to perform ETL and or ELT, because Clover will allow you to do either of those, right? You can transform the data on the way in. And so when the continuously ingested files are already well shaped and well prepared for Snowflake, or you can take advantage of Snowflake's processing power and transform after the load. But a third-party tool like Clover is going to give you the choice. And in fact, allow you to do some fairly clever combinations, right? ETLT, where you do two transformations. You transform on the way in as part of the continuous ingest, but then you transform again after the data has landed. And you can do that as one single unified process without worrying about any sort of separate scheduling. As soon as this process runs, it's going to extract, transform, load, transform, all in one time efficient single process. And of course, use a third-party tool like ours when you want a graphical tool to design and test what your ingest process looks like. But in any event, good luck on your ingest project. We'd love the opportunity to talk to you individually about your specific requirements or your specific projects, but of course, also happy to take any general questions now. So Kate, I'll throw it back to you.
Thanks, Kevin. And yeah, thank you for that session. I hope everybody found that interesting. If you do have any questions, just pop them in the Q&A box and I'll throw those over to Kevin for some answers. While everyone's doing that, I'll just talk quickly about our upcoming webinars. So next week, so this same time slot next week, on October the 5th, we have a session on strategy for data migration to cloud. So if that's something you're in the process of or thinking about, then come along to that one. And tomorrow, and actually every Wednesday, we do a session which is a live demo of CloverDX. So basically, if you want to see a little bit more about Clover, maybe ask some questions to the engineer who's presenting that session, it's all live. So we'd love to see you on that session too. So I've just put those links in the chat there, and we will send those out via email as well, if you want to come along to any of those webinars. So let's just take a look back at our Q&A. We do have a couple of questions that have come in. So Kevin, I will start with this one from Joseph. He asks, is Snowpipe ETL?
In our experience, Snowpipe is more ELT, right? It essentially expects the data that you are ingesting to be in a shape that is ready to be loaded into a Snowflake table, right? So if you put if the file that you hand Snowpipe has 6 columns, it's going to create a table that has 6 columns, or load it into an existing table that has those 6 columns, right? If the file is JSON, it's going to put it in as a single object called, that's JSON. Now there are some, transforms that you can do afterwards, right? To further reshape. But our experience with Snowpipe is that it's much better suited for ELT. And if someone in the audience has a alternate experience or alternate luck there, please jump in.
Okay, thank you. Okay, next question. Does the Snowflake serverless loader transform the data as well?
Again, it sounds remarkably, I think I'm going to interpret that as being essentially the same question. I do not believe it does, right? Snowpipe is very good at chunking the file, and Snowpipe is very good at chunking the file and getting it uploaded, and to do it without you having to worry about spinning up the right sized resource, and to do it as fast as possible. But there's no transform. Certainly not traditional transform that we business users think of, like cleansing or shaping or validating individual fields, or changing the structure of a particular field, or doing lookups, classic business type transformations that we do. That needs to be done either before you load it or after you load it. Okay,
and a CloverDX specific one here. What's the largest set of data CloverDX continuous ingestion tool can handle?
Tough to answer. Our file, if we use our bulk loader, we're going to split the file into pieces. And we can do that, and we can push the data as fast as the constraints there are going to be how much memory you're going to configure CloverDX server to have, and your connection to Snowpipe. Mostly it's going to be the memory, I believe, but we can certainly handle gigabytes of data at a time. So happy to go over in more detailed use cases. It's really hard to comment generally on that. I think our documentation says there was someplace here in the slide, one of my earlier slides, where I think we had where did I go here? Here we're saying 25 megabytes a second, right? Is how fast we can push data into Snowflake, right? And the amount of data, again, continuous, right? It's all a puzzle, right? If you have a massive file, we can continuously load that. But if you want us to load that file every 2 minutes, and the file itself takes 5 minutes to process, well, there's some engineering assessments we'll have to do, right, to figure out either how to make them smaller or increase the time interval.
Great, thank you. And so I hope that answers the question. And just to say, if anybody does have any kind of longer questions, or you want to chat with somebody about any of this, then we'd love to talk to you. So please do feel free to get in touch with us. I'll just pop the link in the chat there to our contact page on our website. So if you want to drop us a message, we will get right back to you, and we can talk about any of this. Okay, back to the questions. Someone is asking, how is CloverDX ETL better in comparison to other ETL tools we have, such as Talent, Alteryx, Informatica? What are the key features of CloverDX ETL?
Embarrassment of riches in the ETL space these days. Those are all tools that we were familiar with. If you look at Gartner's Magic Quadrant, you'll see all of those players, ourselves included, are on the quadrant as top providers of ETL. We, I guess, pride ourselves on our approach with we think our visual design environment is top of the list, and we think that the automation piece, our ability to orchestrate some complex pipelines and to do it simply is very competitive. So always an interesting bake-off between the list of products that you mentioned there, and we're happy to be included in your list, right? So definitely, if you're thinking in terms of those vendors, then you're on the right track for building a good pipeline.
Cool. And while we're on the topic of Clover, somebody else has asked, can I host CloverDX locally or on the cloud?
That's another piece of flexibility that we have with our tool, because CloverDX can run either in the cloud or on-prem. So a lot of times, if you want to ingest data continuously from Snowflake, that data is on-prem, right? And that can make a tool like CloverDX, pretty attractive, right? Because we can grab the data, we have access to. You install us on-prem, we can connect to your on-prem systems, all of them, grab the data, do some preliminary shaping and quality assessments, and then push up to Snowflake in one single operation, right? Or you can run us in the cloud, in which case we can connect to your cloud sources. Maybe you have 4 separate cloud sources, each providing an API. We can connect to all 4 of them, grab that data, and maybe join it all together and push it into Snowflake, or push them separately into Snowflake, right? There's a lot of options, right? But we can run either on-prem or in the cloud.
Okay, and moving over to the Snowflake side of things, somebody asks, can you talk a little bit about why Snowflake is so popular? And do you think it's going to match the high expectations?
Well, expectations are high, certainly, but it's hard to say. It's hard to say. We see a lot of clients having good success with Snowflake, so there's some fundamental truth there. Whether that truth lives up to the hype, particularly in the markets, I guess, none of us could really answer, or we'd all be rich. But it's good, solid software, and we have a lot of clients that are doing some very clever things with it.
Thanks, Kevin. We have had a couple of questions in about the recording of this session and the slides. Just say those will be available. We'll send those out by email to you probably tomorrow. So keep an eye on your inbox if you would like those. Okay, and a question from Angel. Does CloverDX have templates to clean common data issues, similar to using regular expressions using Python or pandas? Can it be used in data scraping projects, for example?
Yes to all of those things, right? We've got components that make it easy to define rules for data cleansing or data validation. And one of those rules can simply be apply, a pattern match using regex. We are at our heart an orchestration engine, right? So if you have some logic in Python that you want to keep, you can still build a Clover pipeline where one of the stages of the pipeline is to run Python, right? So go grab the data, bring it into some staging area, tell Python to do some pandas kinds of things on it, take the result set from that, and push it into Snowflake, right? So to us, first of all, we have built-in components that allow us to do the kinds of things that you do in pandas. Second of all, if you already have an investment in Python and you want to preserve that investment, you can still use a tool like CloverDX to orchestrate the execution and make it just, step 3 of a 5-step push to Snowflake process, But that's a cool sounding question. I like that.
Yeah, and if anybody does want to play around with Clover and see what it can do and maybe try building some of those pipelines, I've just put the link to our trial page in the chat there. You can access that via our website. It's just there in the top right corner. You can download a free trial of the full version for 45 days and do whatever you like with it. And again, we're happy to help out with any questions people have while they're doing the trials. We love talking to people about what they're trying to achieve. Okay, I'll just have a final check back on the Q&A box. I think that's everything we have in for today. So if nobody else has any last minute questions, then I think we will wrap up. So thank you very much, Kevin, for a great presentation. And thank you to everybody for attending. And we hope to see you on another one of our webinars soon. Enjoy the rest of your day.
Thanks very much, guys.